Hello, we're going to do 8M7, lesson 14, decimal expansion of pi. And there are a couple of key pieces of information, different types of things we're learning today. So let's get on with it and let me tell you about what those things are. Okay, so we're going to start with, sorry, let's go here. And this is, we're not really going to talk so much about the decimal expansion of pi. That's the title of this lesson, but we're going to talk more about a couple other things. The formula for an area of a circle and the formula for the circumference of a circle, which you have learned before. But we're going to remind you of those two things. And then we're going to look at two good estimates for pi, and we're going to calculate some areas of circles and circumference of circles using those estimates. And then we're going to do a what seemingly totally different thing, which is we're going to, this is most of your homework, or the majority, which means most of your homework is right here in estimating squares of non-terminating decimals. This is something that builds on some stuff we've learned so far, so we will make sure that we cover this really well. So let's start off though, and let's just remind ourselves the area of a circle and the circumference of a circle. These are two, these are two key formulas for geometry. If you know anything about geometry, if you've taken any geometry class, these two formulas you are expected. Any math teacher will expect you to know and have memorized these. So let me give you a few hints. Sometimes students get a little confused about when they remember these, which one goes with which. Now the first thing about the area and the circumference of a circle is you have the same symbols. You have a pi, an r, and a 2, and a pi and an r and a 2. They're just kind of written a little differently. So the area is the one that is pi r squared. And circumference is 2 times pi times r. And the way, I don't know, one way I remember it is that area, the answer for area is always square units. Right? So when you find the area of a circle, it'll be like 5 meters squared, or 42, centimeters squared. And so when you think about it, the area has the squared piece in it. The area has the r squared, whereas the circumference doesn't have the r squared, because circumference is a distance around a circle. Right? It's these arrows. It's if I was walking around a circle, how far would I go? What distance would I travel? And so that would be like, the circumference could be like 10 meters or 42 yards. Right? So area is the amount of grass I'd have to cut if I was cutting a circle of grass, or it's the area I'd have to paint if I was painting a circle. This green piece here, okay? So if that doesn't speak to you, the way that I memorize the formula of pi r squared being area, because r squared, the squared units are always area units. You can just memorize these two formulas without any kind of keys to learning it. But that's kind of how I do it. Anyway, so let's use these two key formulas and do some calculations. Just make sure we know how to use them. And then we're also going to look at the two good estimates for pi when we're trying to figure out, when we go to the store and buy some paint to paint a wall, how much paint we need to buy, or how much fabric we need to buy to cover a certain area. We have to turn that pi into a real number, and then we have to go to the store and buy a certain amount. So we have to estimate. So we'll get into that in a second. Let's go and let's make sure we first know how to use these formulas. Okay, so let's remember we have the 2, the pi, and the r, and our area is equal to which one? It's the one with the squared in it, because that's the square units. So pi r squared, which leaves circumference being 2 pi r. So we'll just write those down over here. So let's find the area and the circumference of these circles using pi. And all we're going to do is take our radius, which is our r, and we're just going to plug it into the formula. So our area of this first circle is area equals pi r, which is 2 squared. So our area equals pi times 4. And we always put our pi last, so we're going to do it like this. 4 pi. And our units are centimeters. And because area is always square units, it's centimeters squared. Over here, similar, we're going to go area equals pi times r squared, which is equal to, use your calculator, which is 2.25 pi. And what are our units? Yards squared. So that's our area. That's our area. Now we're going to do circumference. Circumference equals 2 pi r. So that's 2 times pi times 2 is 4 pi. So our circumference is, interestingly, also 4 pi. Doesn't always work out that way, but it just happens that 2 times 2 is the same as 2 squared. So in this case, it works out. And our units are just distance, so it's centimeters. Over here, our circumference is 2 pi r. 2 times 1.5 is 3. So our circumference is 3 pi yards. Okay. Now, if I go to the store and I want to buy 4 pi, oh, this is centimeters squared. Oh, no, it's centimeters. If I want to buy some paint to paint this circle and I need to buy paint that'll cover 4 pi centimeters squared, the guy at the store is going to say, well, wait, I need a number. I need you to estimate what that's going to be. And so I don't sell things by the pi units. I sell them by, 1 square centimeter or 10 square centimeters or 100 square centimeters. I don't sell it by 4 pi. I don't know what that means. So when we use when we want to find kind of a good approximation, we either use 22/7 or 3.14. These we're going to plug in. So let's estimate the area of this circle. So let's do that. Let's estimate that in green. So we will do this. We're going to plug in. Let's start with 3.14. So we would estimate it at 4 times 3.14. And I'm going to get out my trusty calculator. And 4 times 3.14 is 12.56. So that's about 12.56 centimeters squared. So this is our estimate. These greens will be our estimate. Right? Pi is not exactly 3.14, it's about 3.14. Now, I can also use a fraction. And if I use this fraction, I would get, plugging it into my calculator again, I'm going to get 12.5714 ... centimeters squared. So 22/7 is a little closer to pi than 3.14. So this is a usually, if you can use this one, it's a better estimate. But 3.14 is sometimes is usually good enough, right? 12.56 square centimeters is pretty close to 12.57 centimeters, which again, they're both just estimates, but they're pretty close to each other. So let's estimate the circumference using both numbers, and it's actually going to turn out to be the same thing, right? Because you're going to get 4 times 3.14. So that's 12.56 centimeters. And again, it only works out in this case to be the same because I have the radius is 2. That's the only number where those two numbers meet up. And maybe that was a bad example for me to choose. But here we're going to do the same thing here using 1.5. And we'll do it one more time. So if we estimate our area using 1.5, using 3.14, our estimated area is going to be 2.25 times 3.14. And that's, if I punch that into my calculator, I get 2.25 times 3.14. That equals 7.065 yards squared. And that's an estimate. Again, these are estimates. Or I can get 2.25 times 22 over 7. And let's see what that gives me. 2.25 times 22 divided by 7 equals, that's equal to 7.0714 ... yards squared. So again, if I go to the store and I say I need to have enough fabric in square yards of fabric to cover this circle, I can't go in there and say 2.25 pi yards squared because he won't know, the salesman won't know how to sell me that amount of material. But if I said I need 7.065 square yards, then he'll know to give me a little bit more than 7. He might give me 7.1 square yards of material or paint to paint it or whatever I'm trying to do to this circle. Similarly, if I'm going to estimate my circumference, I would go 3 times pi, which is 3 times 1.14. This is a good estimate for the distance around the circle, and that would be 9.42 yards. Or if I wanted to use 22/7, I'd go 3 times 22/7, and I'd get 9.428 ... yards. And again, why do you need a circumference? Let's say I was trying to build a fence around a circular piece of property. I would need to buy fencing that would stretch 9.42 yards. And again, I wouldn't say I want 3 pi yards to the guy at the store. I'd say I need 9.4 or 9.5 to round up, 9.5 yards of fencing. That's why we use estimates, or one good reason we use estimates. Okay, so hopefully this makes sense. Again, 3.14 and 22/7, those are the key things to take away. Those are good estimates for pi, as well as memorizing these formulas for circumference and area. You absolutely will need to memorize these for your SAT when you take that someday, or your PSAT, or your ACT test. Some of these college entrance tests will expect that you have memorized these formulas. And if they will also expect that if they say use 3.14 for pi or 22/7 for pi, that you'll know how to use those in calculation to perform estimates for the areas and circumferences of circles. Okay, let's move along. Now we're going to switch gears and do something really different right now, but it's going to be more similar to what we've done in lessons 13, 12, and 11, where we estimate numbers squared. And this is kind of like the opposite of square roots in a way when we were estimating square roots. So let's look at this. If we take 3.36 ... these ... mean, numbers we don't know. Numbers we don't know. And it implies that they go on forever. So it could mean 1.361111, or it could be 1.369842 ... But it means a number of digits beyond 1.36. So what do we know about this number? Well, one thing we know about this number, what is the lowest bound for this number? Well, the lowest bound for this number is 1.36. And that's going to be less than or equal to 1.36 dot, dot, dot. And what number is just bigger, is guaranteed to be just bigger than this number? Well, that is 1.37. We know that 1.37 is bigger than whatever this number is. We know that 1.37 is bigger than this number, and 1.36 is either equal to this number or less than this number. Because if these were all zeros, then this number would be 1.36. But if there's any digits in here at all, like 0, 1, 2, this number is, dot, dot, dot. This number is then bigger than 1.36. So if we were looking, say, at a number line, and I'll erase this in a second, but if we had, 1.35, 1.36, 1.37, this number here is somewhere in this range, somewhere between here. It's not 1.37, but it could be 1.36. So it's somewhere in this interval here. It's not down here, and it's not up here. Okay? So I'm going to erase this. So one thing that we do know is that if this is true, then this is also true. So 1.36 squared is less than or equal to 1.36 dot, dot, dot squared is less than 1.37 squared. Right? We know that's true. Just like before when we knew that if 4 is less than 5 is less than 6, then we knew that 25 is less than 16 is less than 36. If we square all these numbers, we're still going to keep this equality or this inequality being true. So the whole idea of this next section is we're going to do this over and over again. We're just going to find the lower bound. This is the lower, and this is the upper bound. And then we're going to square the upper bound, lower bound, square the upper bound, and we know that this number has to be between. So let's do this. We're going to do it like, watch how I do this. 1.36, this is the lower. 1.37 is the upper. And then 1.36 dot, dot, dot is the number itself. So now we're going to take the number and then we're going to square it. So 1.36 squared, this is squared. So 1.36 squared is equal to and I'm using you can use a calculator. 1.36 squared is equal to 1.8496. And 1.37 squared is equal to 1.37 squared is equal to 1.8769. So I know that this is in between those numbers. So this number has got to be 1.8, because that's exactly between, but it could be 4, 5, 6, or 7. So it's 1.8 dot, 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 dot. So that's the best estimate I could perform, is that it's between, I got to write it like this, 1.8496 is less than or equal to 1.36 dot, dot, dot squared is less than 1.8769. So I can fill in this 1 and this 8, but I can't fill in any more. So I'm going to estimate that at 1.8. Does that make sense? I can't fill in, I can't put a 4, a 5, or a 6 here because I don't know what digit it is. But I do know that if it's between these two numbers, that these digits will hold. Now let's try the same strategy with 4.012. Okay, so here we go. We're going to say, well, our lower bound on 4.012 is 4.012, and that's less than or equal to 4.012 dot, 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 and that's less than 4.013. You know, you just take this last digit and you go one bigger to get there. And that number is guaranteed to be just bigger than anything, any other digits I can put here. Right? So we look at these number and we copy it exactly to here. And then here we look at it and we add 1 to last digit. So we're going to do our lower bound, and we're going to take 4.012, and then we're going to take 4.013, and we're going to square both of them. And we're going to do, so 4.012 squared equals 16.096144, and 4.013 squared is equal to 16.104.169. Wow. Well, all I can say is that the best estimate is going to be right here. I can't go out another digit because I don't know if it's going to have a 0 or a 1 in it. So my estimate for 4.012 dot squared is equal to 16. That's my estimate. Can't go any further. Okay. Let's just do one more of these, and I'm going to try and I'll come back to that next page. So let's estimate and figure out how many digits I can take it out to for 2.56924 dot 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 squared. Well, I need to find my upper and lower bounds. So my lower bound is just that number without the digits added on. So it's 2.56924. Now, in my upper bound is this number with the last digit 1 added to it. So 2.56925. Now we're going to square those numbers. Right? Now we're going to square those numbers to find out what this number squared has to be between. Because this number is less than and this number is greater than. So we know that this number is between them. And if I square it, it needs to be between the squares of those two numbers. So let's do 2.56924 squared. And that's equal to 6.600994178. And 2.56925 squared is 6.601045563 using my calculator. So now we got to figure out, well, we can take that digit's the same, that digit's, so this is, there's as much as we can take that are the same, and then the digits diverge. So I don't know if it's a 0 or a 1, question mark. So my estimate is going to be 6.60, my estimate. Hopefully this is making sense. And so that goes out, you know, you can say that's guaranteed, you know, guaranteed to 2 digits, right? I can't go 3 digits because I don't know if my third, or 2 digits after, when I say 2 digits, I mean 2 digits after the decimal, I can't go to this third digit after the decimal because I don't know if it's a 0 or a 1. So let's just take some time and let's just put down a happy cat. And I'm going to now go and I'm going to give you 2 problems for your homework. And you need to estimate these 2 values and state to what digit the approximations are accurate. And you need to, so this is your homework, Kel. I want you to pause and try. Okay. I assume you've paused and tried, and we're going to use the same strategy that we've been using. So I need my lower and my upper bound. My lower bound is 1.98. My upper bound is 1.99. And so now I'm going to square both of those numbers. And I'm going to use my calculator. Hopefully your teacher is saying that's okay. 3, this is squared. I'll just make a note of that. 3.9204, and 1.99 squared is 3.9601. So as far as I can go is this digit here, and so my estimate is 3.9, and so that's 1 digit after the decimal. We'll do the same thing here and we'll get our lower 0.444332 and my upper, which is 0.444333. Let's square those. 0.444332 squared is 0.1974309,262, and 0.444333 squared is 0.1974318,149. So let's see how many digits we can take that one to. Well, we can take it 0.19743, and then it differs. So our answer here is our estimate is 0.197. Well, we know we're accurate in ... We actually know that we're accurate to this decimal. We're accurate to 5th decimal. Right? Because we know that this one is exactly that to start, and this one is exactly those 5 to start. So we know that anything between their squared has to have exactly those 5 digits. So we're accurate to these 5 digits, and then we don't know what comes afterwards. So let's lay down our happy cats, and let's congratulate ourselves on learning a new skill on how to estimate squares, or how to get accurate estimates of square numbers. Hopefully we also have remembered our 2 formulas for circles: circumference, 2 pi r, area, pi r squared. Area is always square units, so that's why we use pi r squared. The other one, circumference, is just 2 pi r. We'll be back with 8M7 lesson 15 tomorrow, and happy math, happy cat to you.